Okay, welcome back to whatever this series is, or whatever I'm doing here. I haven't quite figured that out yet. Today is a little different. Instead of live coding through a tutorial or on a project, I'm going to do a brief, maybe not brief, code review of something that I've been working on in my spare time. So I decided to build a very simple query builder for the Sqlite database because I needed something to work on and I wanted a query builder. Eventually I'm going to integrate this into a bigger project, but for now we'll just go over the query builder. So let's get started. This was all done via standard industry practice of test-driven development and Typescript. So let's go. I guess I'll start from the top. I started off using the Sqlite 3 module from, or the Sqlite module from Ghost called Node Sqlite, which is this one. And it actually kind of didn't work. I got to the actual calling of the database, actual writing to the database, and it never called the callback to actually write to the database. So that was a problem. Ended up switching to this better Sqlite 3 module that solved the problem immediately. After that, we have all of our type definitions. This is just an alias for any sort of atomic value. So string, number, or Boolean, since JavaScript only has essentially those three types of atomic values. Then there's the update where. This is the type that gets used when you are doing an update. So it gets called like this in the tests. So q.update, table name, and then the actual data that you are updating. So column update column A where initial is 1 and final, and set 1 to stuff. It's just a test. It doesn't really matter what it actually says, but that's the way I have coded this. So, and then if you want to, you can do something like update where initial is 1, initial is less than 1, and set all instances to stuff. So fun times. Here's the definition for a column. So when you are actually creating a table, you give it you give the call to create table this object that tells you what the column name is, any constraints that you may have, the data type, and whether or not it's an auto-incrementing column, and if necessary, a default value. This type here is the result of calling the better Sqlite run statement or run function, where this type defines how you set up a where clause. So it produces a reasonable where statement. So select Steve columns 1, 2, and 3, where column select where column A is 1, B is 2, C is 3. Obviously, this query won't actually work because the columns don't match. But I'm not actually executing this in the database. I'm just validating that I've created the correct syntax and provided the correct parameters. So alter action defines all of the possible ways to alter a column. We'll see that later on in the code base. And that's all of the types that I have defined for this. Now we actually get into the meat of the functionality here. This class is called Q because it's a query builder and naming things is hard. So it has 5 properties: the database itself, any parameters set as an array of values, an error message, whether or not there is an error, and then the actual query. The constructor takes a string that will be created that will be the file name of the database. So it could be, I haven't tested this, I probably should. It's either a path or a file name or memory for an in-memory database. We set the query parameters to empty versions of their respective types, the error to false, and error message to empty string. From here, we start actually building queries. So this ensures that what happens here is we instantiate the class, then we call the select method and assert that we get an actual select statement out of the select method. That's not hard because we can just use string interpolation and join the array of columns with the correct separator from the table. This gets more interesting later on, but for now that's how this works. Same thing with the select distinct statement. Select distinct, except for we just add the distinct keyword in there. So that's not really worth evaluating any further. Again, tests ensure that everything gets created correctly. The join thing is a little bit more fun. I have this this helper method called ensure query starts with select then, that makes sure that the beginning of the statement or the query is a select, because it doesn't make sense to do a join if you haven't first done a select. So ensure query starts with select then takes a string for the error message and then a callback and returns. You'll notice a lot of methods return this. That enables the traditional JavaScript idiom of thing dot other thing dot final thing. So if you ever wondered how we get this chaining, it's by returning an object or by returning the same class. jQuery does the same thing. So what happens here is we ensure that this.query begins with select, and then we call this callback here. appending the correct join statement to the select. And in the tests, it looks like this. There we go. So you just pass in, oh wait, that's not the test, that's the same thing. Let's jump back to the tests. You pass in join of select thing, select column, and then you join a new table, select a new table on the correct identifiers, and it produces that. So that's how that's that. Where is similar, except for here's where we get into the columns data structure that is defined above, or the where data structure that is defined above. So if we jump up to here, select where column is a string and value is a value and a comparison. So what we can do is take an array of those, map over them, oh, I should rename that. There. We take the data structure for where, map over that here, and construct a where statement from that. This the parameters for this map columns are useful later because I need to have a different word, or in this initial case an empty string for the first instance of the where, and then I need to append an and to every subsequent query, or to every subsequent, yeah, we'll say every subsequent query. So you end up with something like this, where you have select 1 2 3 from Steve, where A equals something and B equals something and C equals something. In MySQL, that statement would look like and where B and where C. So yeah. And then once this map returns, because the map returns an array of strings. So once the map returns, we can append where, oh, I could do this even nicer. Maybe. I'll have to test that. But I think I could move this where up to here and then eliminate the where from line 69. So since map columns returns an array of strings, we can do params.join and end up with the correct statement. And then we have to build the values. So we take the columns and extract from the where data structure the value of that and set that to the parameters. And because we have a previous statement that may have parameters of its own, we have to do this. We have to join the two, and I chose to do this with the splat operator with the triple dots. But I'm sure there are other ways to do it. This was just the most logical way for me to do it. Or where is the same idea. again, this is what the call looks like. And here, what happens is you have to, here the map columns comes in handy because we need a space before the first or, and then the way the string interpolation works, we don't need a space for every other or. And again, the join, and then the same, it's just the same pattern as above. Update is interesting. I decided to not allow you to make the mistake of saying update everything or update minus a where clause. So here we have the update where data structure. Update where column has this value. Translate update where column with this value move to that, or from this value to this value based on an optional comparison. If the comparison is not given, it just finds whatever is equal. If a comparison is given, you can do update price set, update price where price is less than 10 to 11, and it will set all price columns with values less than 10 to 11. So that's one way to do it. Moving on to inserts. Again, all of this is backed up by TDD. So if I change any of this, the tests will fail. So that's, and I mean TDD in the most traditional sense of write your tests first and then write the code that satisfies the tests. That paradigm is very useful because it prevents you from writing a test that never fails. Also, one of my axioms for doing test-driven development is write the test and then write the dumbest code possible to make the test pass. So if we have a test that says, if we take this and just copy paste it over here and change the description to it adds two numbers, we can write a test that says something like expect some, we only need the expect here. We can write a test that says expect sum of 1 and 2 to equal 3. Oops. And then when we're actually developing this, the implementation of sum initially, the better description would be one and 2 and gets 3. So when implementing this, it's const sum equals a b 3. That is the dumbest possible code that satisfies this test. Now, obviously, if we call sum 4 and 5, this test will fail, which is why you add another test that generalizes this to 4 5, 9. Now 4, 5, 9. Now you have to generalize this. You can no longer just return a value. You have to now say return A plus B. So when doing TDD, write your tests first, or when doing automated testing in general, it's good practice to follow TDD, and then it's also good practice to write the dumbest code that satisfies the test. Now, if we want to expand on this more, we can say it adds two numbers unless the first is even, then it returns the first parameter. Expect sum 4 and 5 to equal 4. So now we have to change this even more. Now we have to adjust this more. A, we can't have it's not as readable to have an arrow function. You can't have a multi-line arrow function without brackets. And I'm not going to try to do this with a ternary because just readability. So now we actually have to have an explicit return. And then we have to say if A modulo 2 equals 0, return A. Otherwise, return A plus B. You can do that with a ternary, but readability. So that would be the dumbest possible code to pass this test. Prevents you from overcomplicating things if you always write the dumbest possible code to satisfy your tests. Anyway, side note, back to Sqlite and building statements. So all a query builder is just string concatenation. So yeah, this insert takes just a basic record of string and value, and it uses the keys of that record for the column names, and then the values of that record as the value to be inserted. And the call looks like this. This is another reason to do TDD. You end up with great documentation. It shows you how your API works. So insert into Steve and set A to 1, B to 2, and C to 3. And note how I'm using parameterized queries here. This prevents SQL injection. We'll get to how that actually all applies in this specific instance at the end of the overview of the rest of this. So here's the use of that column data structure here. So, oh well, whatever. When creating a table, it takes an array of columns and maps over them to create the correct, again, strings. It takes an array of columns, maps over them to create a string, and then returns this so that I can chain the next method on it. Here I did use a ternary because it was just easier, like that. So if auto increment is true, then tell it, say auto increment, otherwise, yeah. Also, for some reason, I had a bunch of random commas in here. I don't know why, but the replace here was necessary, and I don't quite follow why I needed this replace. So, because I don't have commas in my data structure here, but without the replace, I was getting weird commas, so let's just strip them out. I don't understand this because I shouldn't be getting commas here. However, it is what it is, and it's an easy thing to fix. So, yeah. And here, obviously, we want commas, so columns.join, but yeah, it weird bugs. Don't know what that edge case was. Add column. All of these next few call this alter table helper function, which is a massive switch statement. And I think I'm just going to, yeah, I'm mostly going to gloss over the rest of the things that call alter table, because the implementation of alter table is more interesting than the calling of alter table. So over on this right pane, we're looking at this function here. So alter table takes in an alter action that is one of rename to, rename column, add column, or drop column, and then pivots on that action, takes a table, an alter action, and a target. It pivots on that action to parse the target out correctly. So if you're adding a column, it takes the column data structure here and splits it out into the correct string to actually add the column. Here I have, oh, that was interesting. I've never done that before. I have the same buffer split, and I've never tried to move between panes or between splits in visual mode, and that just decided to highlight everything. Good to know. I don't know how that would behave in my in Vim. This is Emacs with evil mode, but it might be the same. I'll have to find out later. So again, it takes, if we're adding a column, it takes the column data structure, parses it out correctly, and then adds it to the query. If we're renaming a column, it takes the target data structure, which I don't know if I have defined. Probably should define that. Oh well. It takes the target data structure of a from and a to and splits that out into the correct things. Actually, no, I don't need to define that because the rename column takes from and to strings as input and just makes the data structure correctly in the first place. So I don't actually have to worry about having a types defined for that or anything. It just does the correct thing. Which is also why I kind of don't care if target is the any data structure or the any type here on this helper function, because I have type checking on all of the calling functions. So it doesn't matter. Again, so rename column takes an object with keys from and to and splits it out. The rename to actually just renames a table. So you give it the table and the target, and it will rename the table. Drop column does what it says, it drops a column. So that's all of that. Quick and easy, nothing terribly difficult. Now, actually executing a query. Again, we'll go back and just mention that all of this is covered by tests. I have another note about tests that I'll mention at the end, because it becomes relevant here in just a moment. You'll note that I have one massive monster test here. This is not ideal, but I needed to create a database and then run all of these different kinds of queries on that database. So, monster test with way more expectations than it should have, but it's effectively my integration test. So, I'm okay with that. Especially because I have unit tests covering everything else, making sure that everything else can't break. So, run, in the context of this Better Sqlite module, run, all it does is executes a query and tells you what was changed as a result of that query. So it returns a run result, which is changes and then the last row inserted. So that's that. I'll cover the run query helper function in a moment. That does the heavy lifting here. All actually returns an array of all of the things that you may have selected or done something with. So if you want to do something like this, where you select everything from the column from the table Steve, you select username, given name, and surname from the column Steve, and you get all of the data. This is how you would do that. If you want to just get the first one, you would call first. So this grabs, again, table Steve, the columns username, given name, and surname, where username is help and given name is me. Yes, I used silly test data. It's fine. And then it only grabs the first one. So first uses the get method. I called it first. I could also alias this. It's to get. It doesn't really matter. I called it first because that's what it returns, is the first method. Now, the actual run query function, it takes a callback. It takes a callback and returns either a generic T, an array of T, or Boolean. And that Boolean will always be false. So I could probably set this to false. I don't know if Typescript will like that. Apparently Typescript hates that, so that's fine. What is Typescript yelling at me for now? Okay, it's fine. It'll catch up. My editor will catch up eventually. just run the tests to make sure that I actually didn't break anything. There, we know that it didn't break because the test passed. So yeah, and that time run query returns, takes a type argument and then return and a callback, and then returns either generic t, array of generic, or boolean. If this dot error because you forgot to select before you did aware, it will tell you what your error was and then reset everything and return false. Otherwise, it prepares the query and then calls your callback. So prepare takes a query, and then in order to actually execute that query, you pass in the parameters for the query when you call either get or all or run, and then reset and return. Reset just essentially clears out all of the parameters and the query and resets the error state to what it was supposed to be initially. Now, since I've already got the test suite up and running, let's see if we can do that where thing that I mentioned earlier. See if we can add where to here and remove it from here and have the test pass. By the way, my editor auto saves when it loses focus, so I can just switch over here and run the tests. I can. I cleaned up my code. Fantastic. We like cleaning up code. So yeah. By the way, I'm using the Jasmine test runner. I don't know how much that matters or what, but that's what I'm using, and it's fine. So I'll put this on my GitLab and put the link in the description if you want to use it. I don't really intend on submitting this to NPM or anything like that. So, yeah, that's my query builder. I've kind of chosen to implement only the most commonly used parts of, or the most useful parts of Sqlite. Inner join and left join and all these other random joins are not something that I currently use very often. Same with things like subselects. I've considered implementing subselects, but it's not a common enough use case for me to care right now. Since this is my code, I can always go back and just update it later. It wouldn't be too hard to add like a subselect method that did something. It took like a select and did something with it. But yeah, I don't know. I'll have to figure that out later. Anyway, that's that. Now I gotta preview this and see if it's good for publishing. See you later.